9. So where does this number come from over here? Careful. 81, right? You went the other way around. It's all right. So that goes like that, right? Okay. Now, what about this right here? -4. Does that come from something over here? Does it? If I plug 16 in here, square root of 16 is 4, not -4. Let's talk about that in just a second. If you plug in 16 in here, you get 4. You don't get both 4 and -4, because what if you did get 4 and -4? Wouldn't this not be a function? Wouldn't you have one input going to two outputs? You can't have that, right? So -4 is not over here, right? It can't come out of this function. The stuff that's over here that can come out is the range. Does that make sense? Only the stuff that comes out is the range. The stuff that goes in is the domain. Now, let me address that real quick. If somebody says square root of x and then asks you to plug in the number 16, then it will be square root of 16 equals 4. It's what we call the principal root. It's the positive answer, always. People mistake that with something like this. Let's say you're given an equation like that, and you're asked to solve this equation. Then the first thing you do is take the square root on both sides, right? And when you introduce the square root, when you're the one who actually pulls it out of the toolbox and says, I'm going to take the square root on both sides, when you implement the square root, then you must consider both the positive and negative cases. Okay? Then you have to consider both. But if it's just presented to you as square root of x, then it's only the positive answer. Is that all right? See some looks of, I'm not sure what the looks are. So domain and range, input, output. Let's see, independent variable. So when we are looking at this function f of x equals root x, sometimes we write this y equals root x. And that way we can graph it, like x and y, right? Something like that, and draw the graph. So when you see this, the independent variable here is x. That's the one that you have the freedom to plug in. You plug in 4, you plug in 9, plug in 16, plug in 25. X is the one that has freedom. It's independent. The y depends on what you plug in for x, right? If I plug in 4 for x, y has to be 2. If I plug in 16 for x, y has to be 4. So y depends on x. So this is the independent variable. This is the dependent variable. So these are all things from the past. All right, we all know that the graph of a function, the way we graph a function way back in the beginning when someone gave us a function with -x cubed minus x squared, if we wanted to graph that, we could do a t-table where we plug in different values of x, plug them into that, and calculate and get answers, right? And then plot those points. So let's say we plotted those points, we would get that, right? We get these points here. That really doesn't give you a good idea of what this looks like, right? You would need more points. So, here's 5 points. If I plug in 25 points, I get that picture. 50 points, I get that picture. 100 different points, I get that picture. And at the end of the day, we get, that's the graph of it in red. Yes? So for us, plugging in points is not efficient when it comes to graphing because it just takes too long to get an idea of what the graph looks like, which is why we spend a lot of time in college algebra and pre-cal sketching functions by just knowing the behaviors, like what they should look like if they have certain properties. But that's the first way we learn, plot by plugging in points. Whoa, oops. Forgot to close this cell. Just ignore all that. Okay, the next thing to talk about is what f of x is. It's important that you understand that when you're given a function, right? This right here, f of x, this is your output. And geometrically, f of x represents the height of the function at x. So this is what this little animation is showing you here. when I move around, as I plug in different values of x, f of x is the distance from the x-axis to the point. It's that height. And sometimes it's negative, right? Sometimes you have a negative height, which means it's below the x-axis. So input x, output is the height of the function. This may seem trivial to all of you, but it's day one, right? Okay, we all familiar with the vertical line test? That is the test that we use to determine whether or not you're looking at what? A function. Well, let's be clear on that, because this is usually not stated in an algebra class. We use the vertical line test to test to see whether or not you're looking at a function of x, meaning that we're treating x like the independent variable, and the y depends on x. If that's what you're testing to be able to say that y is a function of x, then we use the vertical line test. Right? If you're trying to do the other way around, trying to say that x is a function of y, then you don't use the vertical line test. You would actually do the horizontal line test. It can be confusing, but we're going to just go with our good old vertical line test. So is this a function of x? Is this graph in blue a function of x? Yes, because no matter where I place a vertical line, the vertical line hits it no more than one time, right? Okay, now if I do a different function like this one, is that a function of x? That is not a function of x because, well, these vertical lines are fine, but as soon as I get over here, right? When I get there, I hit it twice. Vertically, I hit in two places. So if I hit more than one time, it's no longer a function of x. Would this have been a function of y? Yeah, so imagine running, if I say is x a function of y here, you would do this test with your line this way, and it would have passed. So even though that graph is not a function of x, it is a function of y. We'll address that more later, so don't be freaking out about that right now. Piecewise functions. Do y'all remember seeing these in algebra? Where you had like a function, it was this function as long as x was smaller than or equal to 1, but then it changed to a different function if x was bigger than 1. You remember seeing something like that? We're going to be messing with these quite a bit. But the whole idea is that you have here a parabola, right, that behaves a certain way, and then when you get to an x value of 1, it switches to a different parabola. So you have two pieces that create two pictures, but it's still a function because your vertical line test is passed, right? It's still a function of x. So those are piecewise functions. All right. How about talking about the intervals where a function is positive and negative or 0? So if I'm saying, hey, take a look at this function. Tell me where it's positive. All you're saying is, where's the function bigger than 0, right? If I say, hey, where's the function negative? You're saying, where's the function less than 0? If I say, where is it 0? You're actually looking for the x-intercepts, aren't you? That's where a function would be equal to 0. So again, with the picture, here's a graph, right? I'm going to show you right now where this graph is positive. Right here, and then right here, right? That's where the graph is above the x-axis. Now, when we say where is it happening, we're actually talking about the x values. So between, here's 0, here's -1, here's -2. Between -2 and 0, if our x is between -2 and 0, then our function is positive. If we're bigger than 0, right, from 2 to infinity, this way, our function is bigger than 0, above the x-axis. Yes? Okay. I know I'm going fast. Trust me, when we get to the new stuff, I will slow down, all right? So here's where the function is negative, where it's below the x-axis. So we always read this like left to right, like a book. So starting way out there to here is -infinity to 2. Oh, what's that symbol? Union. So that's how we put together two intervals. We use a union symbol. Union 0 to 2, so from 0 to 2, it's below the x-axis. I'm going to write that down. X element, that means element of, that's infinity to -2, union 0 to 2. Okay, that's how I would represent those red intervals, right, with that? Now, what about where is this function equal to 0? Well, that only happens at 3 points, right? Those 3 points. So the way we write that is x is an element of, we don't use parentheses, we use braces, and we separate each number with a comma. So the brace means I'm going to be giving you single answers, okay? And commas between them. The parentheses means I'm going to be giving you an interval, so it's everything between the numbers. And we do remember that there's a difference between a parenthesis and a bracket, right? The bracket means you would include that endpoint. Parenthesis means I do not. Why would I not include -2? Why do I want parentheses here and not a bracket? Yeah, because at -2, your function is actually 0. And we're asking when is it negative? Negative means below, so 0 is not above or below, right? 0 is not a positive number, 0 is not a negative number. 0 is 0. Okay, most people have no problems with the idea of where a function is above and below the x-axis. Here's where things start getting a little bit weird. How about where a function, the intervals where a function is increasing, decreasing, or constant? So what do those terms mean? So what do you remember increasing function to mean? This is the precise definition, but this always freaks people out when they see it. If I tell you that a function is increasing, what do I mean? It's what? It's going up, right? Now, what do you mean up? Rising? Okay, so like if I were to draw this, here I'm going to draw you a function. It's rising.
No. It said right.
Oh, you mean I'm supposed to read it like a book from left to right? Correct. That's what yes. So I'm intentionally challenging you because I want to make sure we're all clear on this. Increasing means that as you read from left to right, you're going up. And decreasing means as you go from left to right, you're going down. And constant means, well, you're just flat. So let's try and interpret that. This is weird. This is the actual definition of what it means for a function to be increasing on some interval I. It says, look, your function's height at x1 has to be smaller than your function's height at x2 whenever x1 is less than x2. What? Okay, so here's the picture. It's going to be kind of hard to see that, but look at this. Can you tell as I move from left to right that this function is going up? It's increasing? But the definition says that as long as x1 is smaller than x2, so as long as this points to the left of that one, then the output of this point must be below the output of this point. So you can tell this one's lower than that one, right? So then it would be increasing. So it's kind of like if you connected them with an arrow like that. Oh, my arrow does. There you go. See, my little arrow is pointed up. And as I move along this function, it continues to be pointed up, doesn't it? Okay. Decreasing would be the opposite. So as we move from left to right, if we connected them with an arrow, the arrow's pointed down. Okay? And then constant is kind of like some of y'all look like your brain activity right now is like this. Only because I'm not interesting you right now. I'm not saying because you can't think. I'm saying because you know all this already. Okay, so look, flat, right? Now there's something important about this. It's subtle, but it's important. See that point right there? Am I increasing, decreasing, or constant at that point? Let me, before you fire out an answer. At that point right there, am I increasing, decreasing, or constant? Let me put it here so there's no confusion. I'm hearing increasing, I'm hearing constant. You want to support their answer with make an argument for yourself? Okay. That's right. In order to talk about increasing, decreasing, or constant, you need 2 points. Okay? Kind of like when we drew that line, the green line a second ago, we needed 2 points. If I ask you if this function is increasing or decreasing at a single point, it doesn't make sense because you need 2 points. So you would tell me sir, you're an idiot because you need 2 points. Or, you know, you would say it's a stupid question because you need 2 points to talk about increasing or decreasing. I can't talk about that thing happening at 1 point. All right? So, just keep it in mind. Now, if you went and grabbed another point to the right of it, it would be above, right? And that means it would be going up. And if you picked a point to the left, it would be below it. So you would have that, you would have that arrow going like that. It would be increasing anywhere in an interval there, but at a single point just doesn't make sense. Okay. So this function right here, let's take a look at where it's increasing. Do y'all see that the increasing, again, when you talk about the interval where it's increasing, you're talking about the x values. So if you take x values from in this red line and put 2 of them and compare them, your y coordinates are going to be like this. This one's below this one. Anywhere on this dashed green part of the curve, right? And this point where it stops right here, that one right there, has nothing to do with x-intercepts. It has nothing to do with positive or negative, right? The function being above or below the x-axis. This could have happened anywhere where it stopped going up. And then where, you know, here, from here to here, it goes down, doesn't it? So from here to here, it continues to go up. So our intervals where we're increasing are kind of unusual, aren't they? They kind of land in weird places on the graph. And so now there's no way that you would have been able to know that it was negative infinity to negative 2 over root 3. Like, that would be difficult just to look at that and know that, all right? Let's see, where it's decreasing is only in here, between here and here, so these x values, so between there and there. Notice on that, I did not, on both of these intervals that I gave you here, notice I did not use brackets, right? I did not use brackets. You could have, and the reason why is because if you would have included that endpoint and come up here to the graph, it's okay to include it because in order to talk about increasing or decreasing, you need 2 points. So if I grab another point next to it, then I can see that it's increasing. So I guess what I'm getting at is because what we just talked about, that you can't talk about increasing or decreasing at a single point, it's perfectly fine to either include or exclude the endpoints. It's right both ways. Certain books do it different ways, but so I always say to be safe, just use parentheses when you're talking about increasing or decreasing. Just use the parentheses, all right? All right, so switching gears a little bit. Let's talk about domains. Let's talk about domains. We already said that the layman term for domain basically means like what can you plug in, what can you not plug in, right? So domain would be the stuff that's good, that's valid. So look at, I've given you 3 functions here. We're going to do each of these. What's the domain of f? We might have to do some work for this. What's that? 2? Where are you getting that from? I want to know tell me what x's are okay to plug into that, and possibly what I cannot plug into that. So what is it that you would need to concern yourself with here? The denominator can't be 0, because then you'd have division by 0, right? So when we see a rational function, that's what this is, a rational function, we are concerned with any place where the denominator is 0. So we ask ourselves that question. Now, I'm not going to put the answer yet. I'm going to do some work. I'm asking myself this question. When is this denominator equal to 0, right? That's kind of a question I'm asking. Because if that's ever 0, I've got a problem, don't I? So what do we do to solve that equation? Factor it, right? So to factor this will be, let me see, x minus 8, x plus 1. All right? So if that factoring right there was a problem for you, we need to get that patched up, okay? We, meaning you, need to go to the tutoring lab, come to my office, and we can practice factoring, because factoring Cal 1, you've got to be able to do it. I mean, it's just... So from here to here, and then what do you do here? Set each one equal to 0, right? So you're going to get two solutions. I'm just going to write the solutions down. So I have a problem if I ever try and plug 8 in, or if I ever plug in -1, right? I'm going to get 0 in the denominator, which means those numbers cannot be in the domain. Everything else is okay. So how do I write the domain then? The x's that are allowed are an element of, okay, that's element of. X must be an element of what? Yeah, I'll be with you in a second. I can hear you, hold on. So we know that 8 cannot be there, right? And we know that -1 cannot be there. Yes? But I can have anything else. So anything this way forever, anything between these, and anything to the right of that. Those are all valid intervals. Everything here, everything between, and everything on. So I write that, parenthesis, -infinity, so that's everything that way, to -1, bracket or parentheses? Parentheses, because I don't want to include -1, right? So parenthesis, union, now from where to where? We want to go to +8, but where do we start? -1 again, right? So it's kind of weird, but we put -1 again, and then no, 0 is just a reference point for myself. Yeah, I didn't need it there. I just so we knew where 0 was. So just -1 to 8, and then don't include 8. So again, parentheses, and then parentheses 8 to forever that way. Okay, that would be the proper notation for the domain. Yes. Oh, hold on. We didn't factor this properly. I think that you were looking at that incorrectly. That was a minus. Okay, that was a mistake on my part. Y'all just speak up. Look, if I do something as ridiculous as that, just let me know. Look, this was a plus in the problem, right? Okay, so this should have been plus and minus. Plus and minus here. Here I'm telling you need to know how to factor, and then I go factor it wrong. Okay, so an easy fix for that, just change the problem up here to minus. Okay, that'll fix the whole thing. Everything, all the other work will still be okay. All right? Change that to minus. We okay with that? No, that should still be okay, because now you get the -8 here and +1 here, so that gives you the -7. So, okay, we good? You sure? All right, what about the next problem? Domain of G. It's weird, they didn't send an email out or anything saying that the AC was not working in here.